20 minutes.
We have 5 minutes.
Hello. First, I must correct you, I'm not a doctor yet. Thank you. Well, I come from Slovenia. This is the title. It may sound like far-fetching, but I'll bring everything to firm ground in a few minutes. So here is a short introduction of my presentation. We all know that Boscovich had a great influence on the development of atomic theory on a conceptual level. So what I want to focus on in my presentation is Boscovich's influence on the development of statistical science. Like Dr. Vucic was delighted to find something in Boscovich's work relating to his own work, I was too delighted to find that Boscovich had done something for a field which I'm related to. Well, Boscovich is the development of statistical science, which in its turn later influenced the development of quantum mechanics, the formulation of quantum mechanics. So I'll discuss this indirect influence of Boscovich on quantum mechanics. Then another point I want to stress, and has already been mentioned by Professor Vucic, is Boscovich's concept of potential and actual space. Because I find these two concepts fruitful for statistical and probabilistic interpretation of quantum mechanics. I'll explain this later in more detail. For the purpose of making my 2 points more clear, I will say something about what I mean by combination of dynamic and statistical law with regard to quantum mechanics, and will first, for an introduction, give a modern perspective on laws of nature, and later on I will give a little bit of attention to the establishment of statistical laws, so that Boscovich's contribution will be better understood. Okay, modern perspective on laws of nature. We can say that the common scientific view that laws of nature are objectively existent in nature. The opposite view coming from philosophy is that they do not exist at all. Not all philosophers would agree, of course, but there are some. For example, Hume, Peirce, and any others. There are moderate intermediate views, like for example that of the philosopher of science Van Freysen, who instead of using the concept of natural laws prefers to use the concept of symmetry. He's an empiricist, so he finds the concept of natural law too idealistic, let's put it that way. I will use the definition of natural law given by 2 German authors, Weingartner and Mittelstadt. The first one is a philosopher, the second one is a physicist. In their monography, Laws of Nature, they say that laws are several propositions formulated in some theory, scientific theory, and scientific language. So here I have some instances of both of the groups. And the example of dynamic laws, we have Newton's second law, Newton's gravitation law, or Maxwell's equation. And there are instances of statistical laws, like Maxwell's law of the velocity distribution of particles and law of radioactive decay. And then we have a whole field in physics using and applying statistics, namely statistical physics. So, to go a little bit more into detail, quantum mechanics, the main theory describing the atomic world, can be used to some extent as a combination of both types of laws. Here are the definitions of each kind of law as the mentioned author give it. So they say that a dynamic law is the characteristic of a dynamic law is that it uniquely determines the states regarding with the predecessor state. Moreover, all parts of the described system are determined. For example, we describe a system of bodies, like planets, and so on. The last two characteristics are not crucial for what I want to say, but I have given them nonetheless. On the other hand, statistical laws do not describe states as uniquely defined from previous states. So we could say that there is no continuous temporal development, in other words. Then another feature is that not all parts of the system are determined, which amounts to giving the results of calculations in terms of probabilities or averages, maybe. So, with this regard, what quantum mechanics has done is that it has introduced temporal development of probability distributions. So it has combined the first element of dynamic laws with the second one of statistical laws and retained two others, which are not important for example. So the implicit statement that comes from this is that mathematical description of the atomic world nowadays is practically unachievable without statistical laws. Some may say just statistical approach, but I use the term law here at the time, statistical laws, in order to show that not only a methodology is present here, but also the concepts that come with it along altogether. So for the influence of statistics, statistical laws on quantum mechanics, it was necessary that first the statistical laws attain an independent status, which was not reached at some point, but was a matter of development, and it came along probably really only with quantum mechanics in the 1920s and so on. So I'll take a close view, and my point is that Boscovich indirectly helped to establish this law, to make them work, giving the title of law. So here is a quick overview of the establishment of statistical laws, which Stigler gives his monography. It's quite instructive. So crucial point for the establishment of statistical laws was Galton's law of linear regression from 1885, and he gave the law when he was studying heredity. But the link, so this made possible statistics as an independent field, and this showed in the rapid development of statistics in the first two decades of the 20th century. All the very well-known statistical tests that we use are from that period, and statistics then was regarded as a discipline. But before that moment, Stigler gives two branches that led to this event, and namely one branch came from astronomy. Namely, statistics was used as a methodological tool in astronomy. The other branch came from games of chance, from probabilistic descriptions of games of chance, like Pascal gave and Fermat and Bernoulli. Those two branches merged in the already mentioned law of linear regression. And there was another branch that reached quantum mechanics without this probabilistic concept baggage, only through giving distribution in physical theory. So from astronomy, statistics entered physical science with Maxwell's law of velocity distribution of particles, and he himself stated that he took the distribution from astronomy, from the curve of errors. Quite direct passage. So what does Boscovich have to do with it all? We can find it here in the first stages of methodological development of statistics. I will go into the next slide. So my point is that the independence of statistics as a field was important for conceptual advancement in quantum mechanics. This showed exact statistics entered quantum mechanics exactly when Max Born, 1927, interpreted the wave function in quantum mechanics as a probabilistic function. So this has been from then on a matter of dispute. Okay, so let's go into Boscovich's work relating to the development of statistics. So Boscovich's contribution was that he gave a unique solution to the problem which is nowadays known as best fits the data. So with this, he had direct influence on Legendre's analytical formulation of the method of least squares, which is well known among mathematicians and physicists nowadays. Boscovich achieved this while calculating the Earth shape, meaning its ellipticity. And here on the right are displayed the data he had that was available to him, so 5 measurements. And he used a geometrical approach, which is quite, well, in Newton's fashion, let's say. So it was not an analytical approach that was later developed, but a geometrical. You can see on the bottom right figure from one of Boscovich's work. It's a supplement Benedict stays in philosophy in 1760. And I myself used the data to fit the data, and you see the points which are in the bottom right figure highlighted in orange are roughly positioned the same as my points. So this is what Boscovich got the slope of the curve, let's say so. But not in an Excel fashion, Excel is the program, but in a geometrical fashion. Okay, so this is his contribution, but now I want to get the other point, which has already been mentioned, namely Boscovich's concept of potentiality and actuality. I won't go into detail because you've already heard about it. So these two concepts are an Aristotelian feature of his thought, and Supek, the already mentioned Croatian physicist, in his monography on Boscovich, mentioned that Boscovich mitigated the conflict between discrete and continuous, that is, between points and lines, with his concepts of actuality and potentiality. It has already extensively been explained how. And this conflict between continuous and discrete lies at the basis of his atomic theory. As Supek mentions, Boscovich's universal force is potential, but actual forces exerted on some concrete particle is actual. So this comes along because the atom points can be only discrete, so the forces acting on them can be only discrete. This is okay. So if we look at these two groups, discreteness can be associated in Boscovich's work along with actuality, and continuousness with potentiality. this is, I think, a step further from Aristotle, who did not explicitly associate actuality with discreteness and potentiality with continuousness. And there is also this distinction of spaces, as Professor Uršić has already mentioned, mathematical continuous potential space and real actual space made of atom points. And here comes my point, that I think those two concepts can be fruitful for the probabilistic and statistical interpretation of quantum mechanics, because I think that what mediates between the two groups is a statistical and probabilistic description or prediction. So this would be kind of an analytical formulation of potentiality turning into actual results. Whereas the other type of law, defined as dynamic law, by the aforementioned two authors, can be seen as operating within each of these fields, to my opinion, even within the discrete one, because when we make calculations with computers, they are discrete, so we have different equations, but on the continuous side we would have differential equations. Okay, to sum it up, this is my view on how Boscovich indirectly influenced not only the development of statistics, but also another perspective on which concepts, which his concepts could be fruitful for future interpretation, meaning, of course, probabilistic and statistical interpretation. Boscovich gave an atomic theory which lacked empirical background. In fact, his curve was to some extent rationally sound. So he needed not only an attractive force, but also a repelling force. So that was not empirically verified, which on the other hand Newton's inverse square law was. So he unified those two perspectives with some kind of speculation, but very rationally sound and very useful, as we have seen in the following development. Well, my point is that the development of statistical laws was an implicit necessity for dealing with the atomic clock, and which indirectly helped to gain a reputation, because the method he developed was later mathematically equivalent to Galton's linear regression law. So there is no, let's say, technical difference, but there is much conceptual upgrading, passing from the method of least squares to the linear regression law. Okay, this is the rough phase.
Thank you for the presentation. Now we have the pleasure to give the floor to Tomislav Petković, professor from University of Zagreb, Faculty of Electrical Engineering and Computing, Department of Applied Physics. Please.
Thank you very much. Historians of science usually like to say there are two bandits in time, Einstein and Gödel. I will tell you one because I have eaten your time so much. I will take care 20 minutes on. Thank you for this Slovenian contribution, because due to the excellent contribution of Professor Uršić and young scholar Lukan, I will skip many of my slides. Just at the beginning, few basic statements. Boscovich was really the first one in history of science and technology who synthesized successfully the universal theory of natural philosophy. Boscovich's theory of natural philosophy was based on mathematics, physics, and natural philosophical, even virtually quantum mechanical concepts which lived in nature. His theory is based on the one single law of forces, that exist in nature. As the knowledge-making scientist, he was also occupied from other fields of techniques, science, and culture of his time. And Boscovich, just in the mathematical and philosophical concepts, he introduced for the first time points, atoms, as the original points. And this is so-called network points existing in the nature as well as in the real phenomenology in the everyday life. So-called Boscovich plot, Boscovich tree, Boscovich curve, or Boscovichiana, curva Boscoviciana. This is 2011, we declared in Croatia, so-called the year of Ruđer Bošković, 2011, that was the year of Ruđer Bošković, perhaps in Serbia and Slovenia. And myself, I have studied again collective works of Ruđer Bošković. And I counted more or less 100 works. This is so-called pie chart, a pie chart of the collective works of Ruđer Bošković. And you see just in the counterclockwise, you are counting some rule 22 plus 15 and so on. In each analysis, mathematical number is here. Mathematical number is the contents, let's say, in the previous analysis, 14 mathematical numbers for Ruđer Bošković. This is physics 22 and so on. Some rules gives 100. I wish you all to live to see 100 years in your life. So I go over. I would like to, let's say, to emphasize the concept and contribution of Professor Jenner, Max Moshe Jenner. I have collaboration with Israeli physicists, and one of the best, according to my knowledge, one of the best historians who described Ruđer Bošković in English-speaking area, that is Moshe Jenner, and he, in his famous classical book, Concept of Force, that means force itself, Newtonian type of the force, and today that is interaction. There are 4 basic interactions. And Max Jenner quoted, let's say, Ruđer Bošković in the most part of the concept of force, that is the part which describes dynamism of Bošković according to Markovšić's contribution and Lukan, that is really the essential, that is dynamism, mathematical, conceptual, even statistical, dynamical picture of the nature, and that is already, everything has been prepared by Jenner. And then Jenner also used translation of the Mancunian Dr. Child. He is translator. He studied Latin language at Cambridge. He came back to Manchester, lived the rest of the time in translating Ruđer Bošković, published in 1922. That is somehow real connection between the Manchester and between the, let's say, Croatia, Serbia, Slovenia, Portugal, Hungary. We published, Marko, you forgot, I kindly ask you to quote also Croatian bilingual translation, that is, let's say, theory of natural philosophy. Croatian. Yeah, that is 1974. That is very big event in Croatian culture, 1974. That is translated on the right-hand column, Theory of Natural Philosophy, published 1974, in the 2000 copies. And just students, I just triggered our students to study Latin and Croatian, let's say, theory of philosophy of nature of Ruđer Bošković with the associated forever decadal and so on. Here these are examples. So Bošković theory, according to Newton, it was geometrical and pictorial representation with a strong basis of mathematics. He knew, let's say, mathematical differential equations. There is a mathematician from Ferrara, and then his expert to verify that, because he was one of the really excellent mathematicians, philosopher, physicist, engineer, Jesuit, and so on, that is not extra dimensions. These all were real dimensions in nature, in religion, and so on. And let me also mention 2 points. There is one point here, that is point E, that is E, point G. It is intersection that is limes cohesionis of the first time, limes cohesionis of the second time, and you can, this is curva Boscovichiana, you can take this part with respect to Newton. You have attraction part and repulsion. So that is, everything is more or less well done in the first part of the capital web theory written by Boscovich. This is standard textbook. There is repulsive and attractive chord. Let me just say a few words with respect to Lukan's presentation. This is very steep repulsive chord that is yet unknown in physics and the particle physics. And this is very steep curve that is very sensitive with respect to make any data fit. Because data, if you are plotting data, there are error bars. And error bars are going up and down. It is this, let's say, repulsive chord that is unknown territory in physics. We can judge, we can imagine quarks, gluons, and so on. That is beautiful dynamical picture according to quantum physics and particle physics. But with respect to the real data, it is always very dangerous to put on the repulsive arc to see any data. And that is 2 years ago when I visited Manchester for the first time. I gave a very small poster, so-called auxiliary poster, my big contribution dedicated to the 100th centennial discovery of the atomic nucleus by Rutherford in Manchester 102 years ago, and I gave one poster on the hypernuclear physics, and then I attached on the same area a very small little poster dedicated to Boscovich, Rutherford, and especially person who went in between. That was Dr. J.J. Thomson, as you probably know. Just few sentences about Rutherford. This is a beautiful example theory of the Rutherford. That is, let's say, scattering theory. One particle, for instance, alpha or beta particles should be reflected by the very heavy particle, very heavy nucleus, and that is one single of the force, electric Coulomb force. And you have mathematical theory based on the data. These are data points. That is also beautiful. These are points. These are Geiger and Maxwell points. And this is geometrical and mathematical scattering formula done by Rutherford. And so many formulas also 200 or 150 years ago was done also by the Roger Boscovich because he was an excellent mathematician. And this is my main point. Today, we have to rely on the very mathematical and physical, let's say, features done by Boscovich. That is so-called theory of punkter, theory of points. These points, these are not mathematical, Euclidean points. These are points of Boscovich, points which have the property, that is the property of force. That is mathematical point plus force. And these are points could be called today by force. These points here, red, green, and so on, could be either quarks or gluons. And that is, let's say, if you take into account only proton, there are 3 quarks, up and down. Summing 3 plus 3 plus 6, that is 12 mega electronvolts of the mass of the proton. All other points, they are gluons. That is gluon condensations, and all points, all punkta together, they should unify by the force. And the first type of the force that is particular, that is heavier, we could say in modern physics composite particles like proton, neutron, and so on. That is heavier particles, and that is already everything described in the mathematical analysis tools by Roger Boscovich. And that is beautiful example how to explore, how to understand the nature in philosophical thinking, in the case of Boscovich, and in the very precise and at the very high level quantum mechanics done by Feynman, that is theory and experiment, which is applied today in the field of HEP, that is high energy physics. This is just a beautiful, historical resource. Here you can see exactly what we saw today. Let me see, that is here. In the first lecture this morning, we see the example of boiling. That is here. Effervescence and fermentation. That is the boiling particles. That is already described in the genius life and science of Boscovich Feynman. You can see here that Boscovich theory is very good to describe how liquids convenient on release bounces or recoil. That is effervescence, that is boiling, fermentation, and so on. This is so in history of science, time distance seems not to be so important. We have to put again, to study and to read again capital words in the science. This is also two great men in physics, that is Lederman. Lederman wrote, he introduced his concept A minus, we say in Croatian, A minus tom, that means non-splitting. Atomos, that is non-splitting particle. Heisenberg himself, as a German philosopher, Physik und Erkenntnis, physics and philosophy, physics and theory of knowledge, Heisenberg himself prepared to say unteilbar. Atom, that is unteilbar, with his numerous essays or comments in the fields of atom Lehre, atom philosophy, or atom Forschung, really Max Planck, Heisenberg, and so on. German physicists, they really contributed substantially to the philosophy of science. Our lecture will be what I'm coming to end. I finished my paper. Niels Bohr also visited Croatia, 1958, and Niels Bohr, as a Nobel Prize physicist, he gave a beautiful talk, evening talk, in the Croatian Academy of Science. That is 1958, October 29, under the title, that is Niels Bohr and his wife visited Zagreb 50 or something years ago, and he gave a talk in the Academia Slavorum, that is Yugoslavian Academy of Science and Arts in Zagreb. Title of his talk was on the relationship of philosophy of physics of the time of Rudolf Boscovich with the physics of contemporary time. That reminds on our approach today, because this is, let's say, just comments with respect to the beautiful young presentation from Slovenia. At one side, we have very analytical, mathematical, pure scientific approach. On the other side, we have blind experience, data, and so on. In between, just in between of the pure theory, Newtonian or Boscovichian, or maybe Kant's theory in algebraic theory, there is a in between. That is example. This is signal and background. That is a discovery of the Higgs-like particle. And we see here that is so-called excess of events. That is the result of the experimental truth plus mathematical multivariate statistical analysis and very, very many tools how to enhance signal to background ratio. And in that region of 125 GeV, you see so-called polynomial fit, and that is signal or observation curve which somehow converges. That should be Higgs-like particle. And that is not, let's say, from the Boscovician point of view, that is not the genuine, that is somehow, we say compatible picture. We play with the data. We optimize signal to noise ratio with some mathematical alas and formulas, and with a certain plus minus 5 sigma, plus minus 5 sigma, that is God's value, that is average, and plus sigma, 2 sigma one side, 5 side from the other, and in the field, in the territory of plus minus 5 sigma, if you pick up all data, that is so-called observatory. That is the truth. That is not the final knowledge. that is observatory, plus minus 5 confidence level of plus minus 1 sigma. That is also crucial for the quantum mechanics. And I am skipping just to the end. That is, according to my paper, you will be receiving, my full paper is for the archive. There are 5 or 6 copies. First of all, the head Boscovich, Magda, and George, and the rest other colleagues. They are very welcome to receive the paper. And I said in my paper that Boscovich method can be, from the history and philosophy point of view, that Boscovich should be said that his achievement should be explained or should be expressed by means of the epistemic formula. More geometrico, simile matematico, more razionale, more empirico, more theologico. And the last, this is Boscovich 3, only for physicists. Boscovich 3 in nuclear physics. When I say Boscovich 3, that means repulsion, attraction. Boscovich, that is dedicated to the author, that is the Van der Waals effective theory approach, 100 years before that. Van der Waals Boscovich described, and Boscovich has drawn his Boscovich 3 forces. And the last to be said in my presentation, I just divided conclusions and outlooks, level 1, level 2, and level 3, and level 2. And then I just at the end, Newton, Leibniz, Boscovich, Maxwell, Poincaré, Einstein, and numerous contemporary particle physics. They all believe in the unity of nature, regardless of their scientific or religious beliefs. But Boscovich is outstanding. Mark was spent a few minutes in the comprehensive way described the animal in the hell. Boscovich is outstanding because he ended theology at the end of physics, theoria and theory of natural philosophy, and at the end there is supplement dedicated to God and to soul, and then including mathematical supplements and concepts of the virtual and real, that is according to Aristotle's real and virtual philosophy. And Boscovich himself, he used to describe who is whom. Boscovich himself, he said that his position, that is his status of Christian, Catholic, and Private. Thank you very much.
Thank you. Unfortunately, we have not much time for all these lectures. The last one for this lot is from Tina Domazet, if I know the pronounce, University of Zagreb, the Faculty of Electrical Engineering and Computing from Russia.
Dear colleagues, ladies and gentlemen, my name is Tina Domazet, and I'm from, like I said, the University of Zagreb. And my paper presentation is the overview of Heisenberg's super interpretation of Boscovich. This is my first time in Manchester and my first time to participate in scientific congress, so I decided to read because I'm a little bit nervous. I would like to point it out that this thesis is also written by my colleague Boscovich, who unfortunately wasn't able to come here, so I will have to present it to you. My presentation, because I'm reading, doesn't have much text, it's all on pictures. First, I will say a few words about Joseph Roger Boscovich. Some things we have already heard, but this is my interpretation of him. So let's start. Joseph Roger Boscovich was included into the same series as the Croatian philosopher and physics who comprehended on the shoulders of Newton, Leibniz, and Descartes, and also Plato and Aristotle of the ancient time, the single universal law of forces that exist in nature in the middle of the 18th century by his method of thought as a draft for the theory of everything, which is important for the physics in 20th as well in 21st century. Boscovich is the father of the original picture of the points atoms as ultimate building blocks of nature, important works for the modern concept of subatomic particles of the 20th century and in the predicted and accepted new particles of the 21st century. The Boscovich legacy, based on his epoch-making work, A Theory of Nature Philosophy, the first edition in Vienna 1758, the second in Venice 1763, and its particle important due to current epistemic challenges and new physics acquainted with new objects and or particles at high energies, as well as for the global interferences between contemporary science, technology, and culture. Boscovich's competence in the world and in technical science. Many of these things we have already heard. Boscovich's contribution to many fields of science was really important. For example, astronomy. He dealt with astronomy and he published 5 books called Opera Pertinentia ad Opticam et Astronomia. In these books, he pointed out his theory of aberration of light, and like Einstein, he taught that speed of light was constant. According to him, everything was relative, both space and time. From 3 observations of sunspot, he defined the rotation of the sun and his diameter. He figured out that the rotation of 6 degrees per Comets moved. He taught that the stars were like small and big suns. Geodesy. In 1741, Boscovich carried out his idea about geodesy as the shape of the Earth. In his book, he paid attention to turning verticals, and according to him, it was the result of disproportional allocation of mass on the surface of the Earth. Optics. In this field, he is known for instruments like prism with variable angle and circle micrometer. In his book, Theoria Philosophiae Naturalis, Redacta ad unicam legem virium in natura existentium, published in Wien in 1758, he said that everything was matter and movement. According to him, the matter was composed of the same factors, only different laws made it different. Bohr's atom is directly descendant of the Boscovich atom. Boscovich reduced atoms to a center point around which there were clouds of attractive repulsive forces, or named Boscovich's field. Although Boscovich was priest, he supported Copernican system. He was highly respected at the time. He became a member of Russian Academy of Science in St. Petersburg. In 1773, France appointed him as the manager of optics for Navy. He was well known as engineering poet and diplomat. At the request of Pope Benedict XIV, he made plans for repairing of apse and dome of St. Peter's Church in Rome, and he worked on draining of St. Stephen. As diplomat, he went to London to disapprove the Dubrovnik did favors for France, as Great Britain withdrew, and in this way he wasn't natural anymore. He also became a member of Royal Society in London. Supek's promotion of Boscovich. Ivan Supek, world-known humanist, academician, scientist, physics, writer, author of 20 books, novels, plays, and about 100 scientific and philosophical texts. He was a long-time universal professor, one of the founders of the Ruđer Bošković Institute in Zagreb, and establisher and editor-in-chief of Encyclopedia Moderna magazine, rector of the University of Zagreb, president of the Croatian Academy of Science and Art. His humanistic philosophy is based on the University of Science and Art. As he would like to say, there isn't an Islamic physics and people in Japan listen to both. His most important philosophical work is the book Ruđer Bošković, Vizionar prijelomna filozofija znanosti i društva, published in 1989, the second edition in 2005. This is not one of the most important works only because he said that he understood Boscovich's thoughts, the thoughts of the philosopher and scientist he dealt with all his life, especially from the philosophical point of view, but also because he pointed out his own attitude and observation about many important philosophers, scientists, and speculators from history of philosophy. He pointed out his own opinion. Taking into the consideration all Boscovich's predecessors and continuators. According to Supek, Ruđer Bošković is not one of those scientists who is remembered because of his important experimental discoveries or forming a law about nature. Nevertheless, he was one of the most important scientists because of his brilliant anticipation of modern physics, equally theory of field and atomic. Supek proved that Boscovich didn't make great contributions only to mathematics and astronomy, but he also tried to develop systematical image of quality method coming from interconnection between mass points with help of central force. According to this, Boscovich's ideas had a great impact on the next generation of physicists. His importance is even greater when we realize that they offer great contributions to later developments, like Nile-Bohr. Assessment of evaluation of Boscovich. The theory of natural philosophy should be especially emphasized in its outer steps. I think that any of 2 points of matter are equally determined in the way that on one distance are getting closer, while on the other are moving away. This determination Boscovich called force. In the first case, it's an attractive force, and in the second case, it's a repulsive force. According to this, author theory of natural philosophy is reduced to the single universal law of force. In his book, Spolna Cognition, Ivan Supek wondered, who would have the courage today to reduce whole philosophy of nature to a single law of forces, and he continued. Even Roger Boscovich did this. It's undoubtedly that Boscovich is one of the last geniuses who imposed creative problems that no one can even solve. Boscovich was a man of the world, and he was familiar with all ideas and knowledge of the time. Working on his ideas and observation, he proved that there was an inseparable connection between philosophy and science. And only people like him could understand a theory of synthesis to support Grecian philosophy. Boscovich didn't split philosophy from science. Ivan Supek prized our famous scientist everywhere and tried to promote his work whenever he could. He was disappointed that many other scientists didn't realize the importance of Boscovich's ideas and his work, because Boscovich came from a small country and there weren't many opportunities to promote his ideas. We can now only be grateful to Ivan Supek that he tried to explain the importance of Boscovich's work, because Boscovich was a really important scientist in our history who wanted to create a world based on science, and in this way make it easier for the next generation. Heritage. Institute for Science Research on the field of atomic physics was established in Zagreb in 1950. You can see it on this picture. And Ivan Supek suggests to name it after Ruđer Bošković. Astronomical Society in Belgrade is also named after him, as well as one creator on the moon. Now I will say a few words about Heisenberg interpretation. Science often builds friendly relationships among scientists from different countries around the world, said Heisenberg in his speech, which was held in Zagreb in 1969 when he was given honorary doctorate at the University of Zagreb. He pointed out that it was very important that all scientists work together. Here we can see Bohr and Supek together in Zagreb in front of the Institute of Ruđer Bošković. Most people realize how important is the impact of external circumstances on their lives, but they don't pay attention to rational scientific thinking that also influence their decision. Moreover, people that live with them have a great impact on their decision. Heisenberg believed that connection power of scientists is based on common efforts of brilliant scientists to work together on some problem. On the one hand, atomic physics made it possible for people to have really strong destroying powers, but it's also made people realize negative effects in this context. Heisenberg also mentioned Niels Bohr's term of complementarity. This term was firstly used in the field of atomic physics, but it was understood correctly when we can also prescribe it in other fields, especially in politics, which wanders between rational conclusions and irrational thinking. According to Bohr, we should take into account characteristical complementarity which exists between rational thinking about decision and decision itself. These both processes are necessary. However, when thinking, one couldn't decide what to do, and the decision interrupts all other things. And the most important thing about Heisenberg's speech in Zagreb is that it's very interesting that Heisenberg never mentioned Boscovich in his original work. But at the University of Zagreb in 1969, when he was awarded an honorary doctor, he speaks about Roger Boscovich as a great philosopher and researcher of atoms in atomic physics, or as a great mathematician, physics, and astronomer Boscovich, who 250 years ago recognized a first theory of atoms in nature, which considerably influenced a later development of natural science. In his most important work, Theoria Philosophiae Naturalis, can find different sequences of thought which only in modern physics in the last 50 years reached their full rise, but proved the Boscovich philosophical views in his science of nature were correct. Although the notion of field of force played an important role only in the 19th century, we found it tolerated Boscovich, who inspired many physicists afterwards, especially Faraday. If we want to summarize Boscovich's fundamental thesis using modern language, that we could say that Boscovich considered the natural law which determining forces among elementary particles is key to understanding the structure of matter. With these views, Boscovich was very close to today's views. It's very interesting to note that the most common term which Heisenberg used in his speech was Wissenschaft, or in English science, and the second place was phrase Kraft den Wissenschaft, or in English power of science. In his speech, Heisenberg emphasized the importance of cooperation so that science could develop further, because if we take into account the history of science in my country, which was established by mathematicians, physicists, and astronomers, then we can conclude that Boscovich's Theoria Philosophiae Naturalis had a great impact, and as such a surprising spiritual and scientific heritage.
Thank you, and we have to thank all the speakers, and we have just to come back at 14 and 10 minutes, okay? Here is